Hi all, this is the voice of Mrs. Backlund. If you would grab your green sheet and get it updated, we've had 4 assignments so far this week, and we'll have 1 tonight. And I should be back tomorrow. Oh goodness, I hope so, unless this disease strikes me next. My boys have been sick. So, green sheet updated. If you would like to check your answers to that last book assignment we had, this was the assignment from Tuesday now. Go ahead and check your answers. A couple things I wanted to point out is on when you're sketching your angles over here, remember the little arrows that show which direction you're rotated. Here we had some coterminal angles. These are the suggested positive and negative values. There's more answers that would be correct. On 60 and 64, remember that S equals R theta. That works only if your theta is in radians. So on 64, you had to do a little work. On 69 through 71, you should have used no calculator. And the reason was because all of those angles were one of our special right triangles. Our 1, 1 square root of 2 for the 45, 45, 90. 1, 1 square root of 2. And our 1, 2 square root of 3 for the 30, 60, 90. So you could have gotten all 3 of those answers from that. Number 72, you had to use a calculator because pi divided by 11 isn't anything nice. Make sure you were in radian mode, hitting your mode button, getting in radian mode for that. We're going to try not to use our calculators at all for this lesson. And the idea is we're going to be able to figure out trig functions of angles like 130 and things like that. Things that we can't actually make a right triangle out of. So it'll be very exciting. The first thing I want to show you is, let's say we have an angle theta. Now this is an acute angle, so it shouldn't be that crazy. Now it's going to hit a circle somewhere, right? Like, we'll talk about how big this circle is, but let's for now say it has a radius of r. So it's going to hit the circle at some point. And just to be general, we'll call that point the x, y. And the idea is you could make a little right triangle there. And this adjacent side would be the x value. And the opposite side would be the y value, because that's how we plot points. X, y, and then the hypotenuse is the radius of the circle. So if we look at it that way, the sine of theta would just be opposite over hypotenuse, y over r. Cosine of theta would be x over r. And tangent of theta, y over x. And then we could reciprocal to get cosecant, secant, and cotangent. Now again, if you'd like to memorize these 3 ratios, that's cool with me, but if you can draw this little triangle and know that it goes x, y, and the radius of the circle, you can come up with those pretty quickly. Here's the type of problem that you'll want to know that stuff for, because if we have this angle, let's pretend we're in standard position, right? And we have this angle, and the terminal side goes through negative 12, 5. Let's just draw that angle. So we've got some terminal side that goes through that point. Now in theory we could make a circle, right? And the radius of that circle would be considered our sort of hypotenuse. Let's figure out what the radius of this circle would be. So if we kind of look at this little triangle right in here, we know this side is 12, we know this side is 5. We've got an x and a y value, yes? And if we do the Pythagorean theorem, I just happen to know this one because I'm a math teacher. The Pythagorean theorem tells me that the hypotenuse is 13. So the radius of the circle would be 13. Now we should remember that this is going to be a negative 12 because we're up in that second quadrant. So this is angle theta. And we're just going to write the 6 trig ratios for that angle. And all we need to know is that x is negative 12, y is 5, because that's the point they gave us, and we figured out that the radius, Pythagorean theorem, would be 13. By the way, the radius is always positive, because it's a radius. So now we can write all of these trig ratios. So remember that sine was y over r. Cosine was x over r. Tangent was y over x. Cosecant, the reciprocal of sine, 13 over 5. Secant would be this reciprocal. And cotangent, the easy one to remember, would be this reciprocal. So when they give you a point on the terminal side, kind of your job is to find that radius, right? So the Pythagorean theorem will always do that for you. And once you have that, you can figure out the sine of this obtuse angle, which we've never done before, so that's kind of exciting. And this will even start to make sense why your calculator is able to do that. Now, it's kind of a special type of case when we have angles like 90 degrees, angles that wind up like not in a quadrant, and then for some reason they call those types of angles quadrantal angles, but they're not even in a quadrant, so whatever. So let's look at 90 degrees. The terminal side is that vertical ray right up here. And so we're just going to pick a point that's on that terminal side. Let's pick a point. I tend to always pick, well, we know it's going to be 0, comma, whatever you want, but I always pick 0, comma 1 just because. And that means my x value is 0, my y value is 1. And then if you think of the radius of that circle, well, can you picture that circle? The radius is 1. The radius is 1. And sometimes they call that the 1 unit circle. And so that's the title of this lesson, is the unit circle. But that's all there is to it. If you can get an x, a y, and an r on the terminal side of your angle, you can throw out these answers like nothing. Sine is y over r. Sine of 90 degrees is 1. Cosine of 90 degrees would be x over r, 0. Tangent of 90 degrees would be y over x. 1 divided by 0 is undefined. So even if you tried to type that into your calculator, say you were in degree mode, and you typed in tangent of 90 degrees, I think it gives you an error. It's undefined. One more, so here's another example of a quadrantal angle, because if you make an angle of pi, remember pi is the same thing as 180 degrees. No way you're making a right triangle out of that. And so what we're going to do every time is pick a point on the terminal side of the angle. So this one's going to be negative something 0. You can pick any something you want. I'm going to pick negative 1. I always do. And then if you picture that circle, again, it's just a 1 unit circle, right? The radius, like from the center to that point, the radius is just 1. So we've got an x value, a y value, and a radius. So no problem. Now we can do sine of 180 degrees. Sine of pi in radians would be y over r. Cosine, x over r. Tangent, y over x. 0 divided by negative 1 is 0, so this one is defined. Those are quadrantal angles. So you have to, I don't think they're all that hard, but we're not making a triangle at all. We're just relying on our x, our y, and our r. Let's talk about when we can make triangles. So let's say we have an obtuse angle like 120 degrees. We can't make a right triangle out of that. So what we're going to do is we're going to use something called a reference angle. And we're always going to find our reference angle by finishing off that terminal side and seeing how far it is from the x-axis. So if this was 120 degrees, That means that our reference angle would be this little angle in here. 180 minus 120 would be a 60-degree reference angle. If we were in the first quadrant, we've got this 70-degree angle. Now remember, I said that you're going to try to take that terminal side to the x-axis. Okay, well, the shortest way to the x-axis is just to use that 70 degrees. So 70 degrees is its own reference angle. That's kind of a weird one. Let's do a third quadrant one. We've got 230 degrees. We want to make it back to the x-axis using an acute angle. That's going to be this angle right in here. This is the reference angle. Now if it was 180, how much extra did we add to get to 230? I'm thinking it's 50. I'm trying not to use my calculator. 50 degrees would be the reference angle. 320 degrees happens to have its terminal side in the fourth quadrant. Quickest way back to your x-axis is just to continue straight up. And 40 degrees, right? To get this whole thing to be 360. 40 degrees is what we call our reference angle. Now we're going to use that. So we are going to find these answers without a calculator. Who needs it? Who needs the calculator? So let's talk about 120 degrees. Step one, we're going to draw 120 degrees. Something like this, right? Okay. Can't make a right triangle out of that, so we're going to use the reference angle. The reference angle is going to be this guy right in here. And that angle, if we're trying to get to 180, that would be a 60-degree angle. Are you seeing it? A 60-degree angle. We love 60-degree angles because we know that triangle. That triangle, let's just draw it. And I'm drawing it in the second quadrant because my 120 degrees was in the second quadrant. So we've got a 30, 60, 90 going on. That's a 1, 2, square root of 3. The thing you want to be careful of is, remember, if I'm going backwards 1, I'm going to have to call that a negative 1. And that's a little tricky to remember. This is a positive y value. Our radius is always positive. So what we're going to do, in order to find cosine of 120 degrees, we're going to use this reference angle. We're going to reference this triangle. So cosine would be the adjacent over the hypotenuse. Negative 1/2 is the answer for that one. Negative 45 degrees. Let's draw that. Always starting on the positive x, a negative angle rotating this way. And the reference angle is just that one that brings us back to the x-axis. Our reference angle is a 45-degree angle, which I love because I know everything there is to know about 45, 45, 90 triangles, yes? Notice that one of the sides of my triangle is always on the x-axis. That terminal side is always my hypotenuse, and I've got a 1, 1, square root of 2. You want to think, are any of those negative? Well, this would be a positive x value, a negative y value, and the radius is always positive. Once you have your reference triangle drawn, we can do our SOHCAHTOA. So sine of that reference angle is opposite over hypotenuse, negative 1 over the square root of 2. Not going to let you leave it like that, so we'll have to rationalize our denominator. Final answer, negative square root of 2 over 2. Now, even if you did type that in the calculator to give you some ugly decimal, we're looking for that exact answer. One more time, 240 degrees. 240. Let's see if we can draw that. So we'd get ourselves to 180. And then go a little further. That's almost to 270, isn't it? Only 30 degrees away from 270. So now where's the reference angle? It's the one right in here, the one that brings us back to the x-axis. And how far past the 180 did we go? I think that's 60 degrees, yeah? I love that kind. If it's a 60-degree angle, I can make myself a triangle where the terminal side is the hypotenuse, the x-axis is one of the sides, and we'll just connect those to make a nice right angle. A 60-degree angle, 1, 2, square root of 3. Are any of those negative? This is a negative x value because we're in the third quadrant. In the third quadrant, x values are negative, y values are negative, radii are always positive. Let's do a tangent. So the tangent of that reference angle, opposite over adjacent. We'd get positive square root of 3. Which if I did let you use a calculator would just show up as like 1.7-ish. Positive though. You're going to have to be able to do this over and over again. I think just to keep this shorter, let's go on to just some examples that have radians, okay? Because I think we probably need practice on drawing these angles with radians. Okay, if I'm going to draw a 3 pi over 4, I'm going to want to split my top half into 4 equal pieces. There's 1, 2, 3, 4. 1, 2, 3 pi over 4s is the one I'm looking for. And that means my reference angle is right in here. How big is that reference angle? Well, 180 divided by 4 is 45 degrees. Each of these was a 45-degree angle. So my referencing, I'm going to write it in degrees because it's not going to matter in the end. We have a 45-degree reference angle. Love that. I've got a hypotenuse on the terminal side. I'm going to use that x-axis as another side. Make a nice right triangle out of that. 45, 45, 90. 1 square root of 2. Which ones are negative? In the second quadrant, just the x value is negative, y is positive. There we go. So, you know, it's not all that hard. If you can get that triangle drawn, then you just have to do your SOHCAHTOA. So we've got a reference angle right here. This is the 3 pi over 4, but we're going to use this triangle. So opposite over hypotenuse, positive 1 over the square root of 2, which rationalizes into square root of 2 over 2. Let's keep going. Dividing into thirds, huh? Okay, so we have to kind of ignore that. So we've got 1, 2, 3. I think I'm going to need the bottom half, so I'll split that again. I've got 1, 2, 3. If you can picture that. Let's draw 5 pi over 3. So let's count them. 1, 2, 3 gets us to 180. 4, 5, and we wind up down in the fourth quadrant, where the reference angle is a pi over 3. Pi divided by 3 is the same thing as a 60-degree angle. Every single time, guys. Every single time you're winding up with a 30, 60, 90. 1, 2, square root of 3. Are any of them negative? Yes. Tangent. Tangent of this reference angle, negative square root of 3 over 1. All right, one more. Pi over 6. You know, it's going to be negative, so I think I'll split the bottom half into 6. So each quadrant needs 3. So that's 6. 1, 2, 3, 4, 5, 6. Initial side on the positive x-axis, rotating clockwise this time, just 1 pi over 6. What kind of reference angle is that in there? Connecting back to the x-axis. It's just a pi over 6. 180 divided by 6 is 30 degrees. There it is again. A 30, 60, 90. 1, 2, square root of 3. Any of those negative? X is positive, Y is down, so that's negative, radius always positive. Now we're thinking secant, which is an upside down cosine. So I'm going to do hypotenuse over adjacent. That'd be 2 over the square root of 3. Can't let you leave it like that, so we're going to rationalize. 2 square root of 3 over 3. You won't have a calculator for this, and your answers will be exact just like that. That's the idea of this lesson. We could do more examples. I'm kind of hoping you got it. Remember, if you get it just a random problem in the middle that's like cosine of pi, it's probably going to freak you out. Because you're going to draw that angle, and you're going to be like, what the heck is the reference angle, right? Remember, if you wind up on an axis, you don't have a reference angle, so you're going to have to choose a point. I always choose a point. Okay, this would be negative something 0. I always choose negative 1. That's when you're going to have an x value, a y value, and a radius. Since I chose negative 1, that radius is 1. And you're going to go from there. So cosine of pi, that's the x over the r. The only time you're going to have to do that thing where you pick a point is if you're right on an axis. Okay? The other ones, you're going to have a reference angle, and it'll make a triangle for you. There's your assignment. You're going to do 25, 30, 35, 40, and then you're going to do multiples of 3. Try not to get off by 1. Multiples of 3. Thanks, guys. I really hope I see you tomorrow.